This is another cute paper, again, kind of a news type article in Nature, which provide nice summary of some topic that are easy to report as podcasts because I learn a lot and then I get excited and think, you should know this as well. Can floating homes make communities resilient to climate risks? We talk about sea level rise, storms coming up, storm surge, inundation increasing, erosion, increasing populations, increasing exposure to these hazards, and of course, buildings have all kinds of environmental impacts. So you have to be careful no matter where you build them. But this is more about building sustainable settlements on the water is a feasible option for climate adaptation as long as people and ecosystems are protected. Anything we do have to watch out for unintended consequences. You don't want to have a tunnel vision on adaptation at the cost of maladaptation for some people or harm to ecosystems and so on. Here is an example. In Qatar, land reclamation projects such as Pearl Island dot Doha's coastline. Is this a floating home? Well, not quite, but they are going into the ocean, reclaiming waters, so land reclamation. China has done these. It happens at smaller scales, let's say even around Mumbai city and so on. And this idea can be taken a bit further, and we can see that here in this report. Sea levels are changing rapidly and could rise by 1 meter or more by 2100 without drastic reductions in greenhouse gas emissions and so on. And of course, there are many regions where people are facing more severe issues of flooding and coastal erosion than others. So this is about flooding in Lagos and Nigerian metropolis. The coastal communities, on the other hand, urban planning and smart technologies are key to climate adaptation and mitigation. Futuristic designs for flood-resilient settlements or climatopias. Utopia, dystopia, climatopia, hopefully happy climate place. No negative impacts. Are gaining popularity, especially in areas projected to be underwater in a few decades. These large infrastructure projects are being touted by governments and developers as tools to expand the availability of housing, reduce pressures on land, enhance energy efficiency, promote eco-friendly transportation, and make less the effects of flooding. Critics view them as technological fantasies aimed at growing the value of the property market near the oceans, lagoons, and rivers. So offering such things can have a moral hazard that more and more people are moving towards the coast, which is what you are trying to avoid, in addition to making resilient housing systems. They also note that climatopias could stifle sustainable adaptation, and we agree that this is a real concern. With the right approach, however, they can be made viable. It's crucial that governments, scientists, environmentalists, think tanks, local communities, and ocean governing agencies evaluate the challenges and benefits of these projects in the short and long term to determine their legitimacy as climate solutions. Here we offer 6 criteria by which to assess climatopias during their planning and implementation stages: design type, practicality, ecosystem impacts or effects, maladaptation risks, justice concerns, and regulatory frameworks. So if you provide these for a lot of rich people, what happens to the poor people? What are the justice issue, equity issues there? So let's look at a few more details. Choose suitable designs. Obviously, the idea of living on water is not new. It's been traced back to around 8700 during the Tang Dynasty in China. On Lake Titicaca in Peru, the indigenous Euros people have long settled on the artificial islands made from roots and reeds. Homes and villages on stilts are widespread from Halong Bay in Vietnam to Chong Kniaz in Cambodia, Ganvi in Benin, Makako in Nigeria, and so on. Amsterdam, Jakarta, Mexico City, Seattle, and Washington have all had long embracing tradition for houseboats and floating markets. So unlike the infrastructure in such traditional communities, Climatopias are designed to be high-tech cities equipped with solar panels for generating electricity, deep-sea cooling systems, healthcare centers, schools, and recreational areas and businesses. There are three major ways in which the developers are converting ocean and nearshore areas into habitable spaces. Reclaimed land, as we said before, so we used the example of Doha already here, but there are other Pearl Island in Doha we talked about, Oxagon City in Neom, Saudi Arabia, Eco Atlantic in Lagos, and so on. But there are criticisms which include their impacts on the environment and on nearby communities. Okay, amphibious houses, on the other hand, are dwellings that are anchored to the ground and buoyed by water. So we'll see that a figure here. Go with the flow. Okay, let's come back to that. This makes them suitable for construction on shorelines, rivers, floodplains, and city harbors or other areas with water levels that rise and fall slowly and predictably. You cannot have floating houses in waters that have massive ups and downs very quickly. Europe hosts many amphibious communities. An example is the Eijburg neighborhood of Amsterdam, which is built on artificial islands and is home to around 45,000 people. Scaling up such projects, however, might encourage people to move into high flood risk zones when relocation elsewhere could be safer. So these things always come with moral hazards. You're trying to solve a problem, but you make it worse by moving more people into flooding zones. Floating cities, these watertight prefabricated structures are situated permanently on the ocean or in lagoons through interlocking modular systems and artificial reefs. The United Nations is urging collaboration between governments and the public as well as the private sector to advance such cities in at-risk places. For instance, the Maldives floating city is designed to house 20,000 residents in units that cost around $250,000 US each, and the Panama floating pods, small-scale structures that each house 2 people, cost between $295,000 to $1.5 million. Although the first pod sank rapidly during its unveiling, the Panama project has been reconstructed and is now available for investors, visitors and buyers. The long-term sustainability of floating cities and their capacity to withstand major storms is unclear, however. Assure practicality, another critical aspect. Planners, engineers and environmental specialists must assess the construction materials, structural integrity, safety, cost, market demand and financial sustainability of Climatopia projects. The name is cool, right? Climatopia. Amphibious Climatopias are relatively cheap. Their proximity to land allows for easy access to electricity. You can wire it in. Freshwater and waste disposal, which can reduce maintenance costs. Reclaimed islands, which demand extensive engineering work and lengthy construction times, are the costliest option. The Ocean Flower Island reclamation project, completed in 2020, took 12 years to build and cost $25 billion. Floating cities need less upfront investment. The one in the Maldives is expected to cost $1 billion, for example, but their maintenance costs can be relatively high and construction materials are prone to corrosion and damage from tidal waves. Salt corrodes everything. Everything you put in ocean water gets biofouling as well. All Climatopias are vulnerable to extreme weather, from storms to tsunamis to hurricane-induced flooding, with significant risks of damage and loss of life as well. To address these problems, governments, planners, insurance companies and affected communities must work together to set industry standards as well as design early warning systems and evacuation procedures. Okay. Safeguard ecosystems, very obvious. Construction of reclaimed islands can cause and exacerbate ocean acidification and loss of biodiversity and coral reefs, nutrient pollution with all the human waste. Dredging of seabed degrades marine environments and pollutes waters, potentially releasing long buried toxic compounds. Hudson River with the PCBs is a good example of that. Land reclamation can deplete natural buffers such as mangroves and wetlands that act as natural carbon sinks and protect against storm surges, waves, erosion and floods. Seawalls or revetments can alleviate some of the risks but do not prevent erosion or subsidence. They also can damage natural ecosystems while creating a false sense of security that discourages long-term sustainable nature-based solutions and planning for relocation. So if planning is needed, will be needed, then where do you move? On to the water or back inland? That's the key question. Amphibious and floating cities can alter local pattern of wind, evaporation, sunlight and heat as well. Increased noise and pollution from such projects can negatively affect fish, crustaceans, mollusks and plant life. For example, although amphibious houses such as those in Harnaspolder and Ichburg in Netherlands have not affected water quality, they have contributed to urbanization, generated noise and disturbed aquatic ecosystems. To reduce the impact on marine life, projects in the Maldives and Oceanics Busan in South Korea propose to use an artificial reef material known as biorock that supports aquatic organisms. Okay, here is an artist's impression of a floating city that is being built in the Maldives. Sounds expensive. Cost of the houses is not trivial, but you can see how lovely it looks. It reminds me of Venice and what is the island nearby? I forgot. The Linen Island. Very nice place. Anyway. To mitigate other environmental impacts, scientists local Burano, that's what it is. To mitigate other environmental impacts, scientists, local communities, residents and non-governmental organizations must demand that urban planners and developers make rigorous and independent environmental and socio-economic assessments. They should insist on transparency in the dissemination of findings. Academics, environmental watchdogs and the media can also improve public awareness about a project's merits and demerits. If this is an irreversible process and the train has already left the station, these things are already happening, then obviously we need to catch up quickly with environmental and socio-economic assessments. Beyond public scrutiny, government and independent agencies must track and monitor the safety of these projects and their compliance with the environmentally sustainable standards. This should include tracking construction materials from source to site, so life cycle analysis part of it at least, mandating the use of reused or recycled materials, promoting periodic risk assessments, implementing protective measures to safeguard against ecosystem impacts. Okay, here's another nice schematic showing about go with the flow, which I was looking for when we referred to it in here. Okay, in amphibious homes. So go with the flow. Amphibious housing can accommodate small fluctuations in water levels. If you're floating, obviously sea level should not be a concern when it's not very rapid and very high. So in the dry season, pitched roof to avoid rain water collecting, raft foundation to float it, so foundation piles there and buoyancy barrels. And in the flood season, the water level rises to begin pushing the structure upwards, and there is a siding that keeps the house within the you don't want it to float away in some sense. The structure rises along the vertical guidance posts to a safe position, so just bobbing up and down. If the rise is slow and steady and not very severe, for example, you don't want to go beyond the guiding posts, which have to be designed based on some projections for the region with safety factors. Alleviate maladaptation. Bringing people and economic activities that would have otherwise been in rural or suburban locations to a coastal area accelerates greenhouse gas emissions and environmental degradation, even if energy efficient systems are used. For example, Eco Atlantic was built on millions of cubic meters of dredged sand and had thousands of tons of boulders and stones transported to the project site, processes that release carbon. Furthermore, paving over natural surfaces can exacerbate erosion and coastal flooding, worsening communities' existing vulnerabilities. Floating cities might need extra energy to maintain infrastructure for water desalination and wastewater treatment, and those facilities can fail. Insurance and repair costs would place a financial burden on residents and governments, potentially diverting resources from other adaptation measures. In fact, insurance companies will play a key role because things like Climatopia must have insurance, and if nobody wants to underwrite the risk, then investors will be hesitant for sure. Right? To address these pitfalls, governments must update local adaptation plans. They must also invest in social services and crucial infrastructure, especially in low-income areas that are experiencing extreme and frequent flooding. So you want to choose regions carefully, remembering that the regions that may not be facing extreme and frequent flooding now may end up becoming extreme and frequent flooding areas in the future. So you have to have some sense of the future projections as well. Prioritize equity and justice, always good idea. Climatopias often cater to wealthy people. For example, an average unit in the Ocean Flower Island reportedly cost $3,100 per square meter in 2019. A massive price per square meter. So think of a minimum sized house and think of the cost. Homes in the Maldives floating city are expected to start at $250,000. These costs are prohibitively high for most local populations, which means rich people may come in and live there, and local people may just end up being labor for the rich people without reducing their vulnerability, which is, one of the goals to begin with. Okay, so there are other issues like new land and properties are usually privately owned. Rights can be curtailed for the public access, and so on. Building of Eco Atlantic, for example, has coincided with several floods. Some local residents have said that they attribute these to the land reclamation activities themselves. So there may be something in the offing anyway, and you are arriving and reclaiming land, and then floods go up, and others who are there before think, you made that happen, right? So governments need to revisit ocean and land rights. Economic growth must not be prioritized at the expense of social justice or cultural diversity. Co-production is always important. We also need to tighten regulations. Climatopias are often built on ecologically fragile areas with few regulations. In the United States, for example, guidance on the construction and maintenance of floating homes exists, but is often not legally binding. So rules may exist, but they are not being enforced. Space at Sea, a multidisciplinary group consisting of 17 European partners, offers technical guidelines that are applicable to floating cities. These guidelines vary depending on legal status. So it depends on the country, even though it's working at the European level. Okay, floating climatopias situated farther out from the shorelines can have ambiguous legal status because national regulations do not extend to the high seas, which means policies and frameworks have to evolve over time if the number of climatopias far away from the coast begin to increase and their pollution and impact on ecosystems, fisheries, etc. begin to affect everybody else. So multilateral treaties such as the UN Convention on the Law of the Sea, the International Convention for the Safety of Life at Sea, and Convention on Biological Diversity offer robust commendations on sustainable development, marine environmental protection, pollution reduction, and the equitable use of marine resources. However, these frameworks have not been ratified by all countries, and the laws do not cover floating cities, which are relatively new structures. on the ocean. You then have to consider all these mandates and reconstituting them to meet these new evolutions of floating cities and climatopias. Governments must also consider environmental, social and intergenerational justice concerns and protect not just affected communities and ecosystems but also future generations. These are always good ideas, but when developers have lots of power, they are easily able to overcome such concerns about equity, justice, intergenerational concerns, right? So where regulations are lacking, governments must establish zoning laws, building codes and safety protocols and update them every 4 years to reflect the latest scientific projections on sea level rise and flood risks. If you allow that to, a floating city to come up and then a cyclone hits it, then the whole debate will be about who is going to rescue them, who is going to pay for damages, whether they should be allowed to resettle in the same place and so on and so forth, which also plays out on mountain slopes where landslides happen and so on and so forth. Developers should be mandated to include affordable housing for low-income groups such as workers and teachers, displaced residents and fishing communities who opt for waterfront living. So there is always a service demand. If you allow a large enough floating city and schools are needed, and this floating city itself is not affordable for the service workers including teachers, then you need to give them space to live close enough and then worry about the issues involved there. No single climate adaptation strategy will work for all communities, of course. An adaptive coastal future requires flexibility and openness. Floating cities or amphibious houses could be part of climate adaptation for some riverine areas and archipelagos. Indigenous communities might make use of them to stop their heritage, identity and islands from vanishing. Other communities might prefer to retreat from the coast. Right? Some people will say, I'm never going to leave the coast, I'm just going to find a way to survive, or maybe reclaim land and even get deeper into the water. And others might say, this is not worth it, and just retreat. Ultimately, of course, climatopias can become technical solutions to a complex global challenge only if stricter planning processes, impact assessments, ecosystem protection and justice for communities are at the heart of any coastal future. Anthropologists will tell you that human beings are aspirational and ambitious, so telling them don't live near the coast, go back, is not going to work in the end. So such solutions, if implemented properly with all the protections for people affected, ecosystems affected and the people who will live there, then these can be more consistent with the aspirational nature of humanity itself. Okay, so I'll leave it there. It's an interesting topic, lots of issues. I have kept it brief, but you can read the paper and the references in there. Okay, see you in the next topic.